This short video is going to take you through the skills and steps you need in order to solve exponential equations. So before we look at how we do it, let's look at what other skills we need. First of all, you must know your index laws, which we have already done in class. So if you're not feeling confident in them, go back and study them. Number two, the key is to make sure the bases on either side of your exponential equation are equal. Once you make the bases equal, solving the equation should be relatively easy. And number three, you need to remember some basic algebra skills which you've probably learned since year 7. With these 3 sets of skills in your back pocket when you attempt these questions, you should be fine. Okay, what's the idea? So we see here, consider the fact that a raised to the power of x is equal to a raised to the power of k. What are all these things? So x is an unknown variable, what we're trying to solve for. K is a known value, which we can compare to x. And a is a common base on either side of our exponential equation. So the concept is, if we get a raised to the power of x equal to a raised to the power of k, because the bases are the same, we can ignore them and just compare our exponents. So in this case, it would mean that x is equal to the value of k. Let's try some examples. First of all, as all these examples we go through, we're always going to be solving for the value of x. Very simply, 3 raised to the power of x is equal to 3. We can rewrite this simply as 3 to the power of x equals 3 to the power of 1, because any value, any base raised to the power of 1 is itself. Again, we see here we now have a common base of 3, so we can ignore that and just look at our exponents. Very simply, in this case, x is equal to 1. Here we have the example of 5 raised to the power of x plus 2 is equal to 25. We need to find a common base, which in this case, 25, is simply 5 squared. So again, we have a common base of 5, they can be ignored, and we just look at our exponents. X plus 2 is equal to 2, or in this case, x must be equal to 0. A little bit trickier now. Here we have 2 to the power of x plus 2 equals to 1 over 4. So again, we know that we can write 4 as 2 to the power of 2. By using our denominator index law, we can take this, move it up to our numerator, changing the sign of our exponent, giving us 2 to the power of x plus 2 is equal to 2 to the power of negative 2. Same base again, they can be ignored, just look at the exponents. So 2 plus x plus 2 is equal to negative 2, or in this case, x must be equal to negative 4. Next one. Here we have 1/2 raised to the power of x minus 1 is equal to 2. Now recall, when you have a fraction raised to a power, both the numerator and the denominator are both raised to that power. So this can be expanded out to give me 1 to the power of x minus 1 divided by 2 to the power of x minus 1 is equal to 2 to the power of 1, simply itself. 1 raised to any power is always going to be 1. So this fraction can be simplified further to 1 over 2 to the power of x minus 1 is equal to 2 to the power of 1. Like before, we'll move our denominator up to our numerator, changing the signs of our exponents, giving us 2 raised to the power of negative x plus 1 is equal to 2 to the power of 1. Same base, ignore them, just look at the exponents at the top. So negative x plus 1 is equal to 1. So in this situation, x must be equal to 0. All right, another example, getting a little trickier. Here we have 5 times 2 raised to the power of x is equal to 40. First thing we have to ask is about our multiplying scalar, in this case 5. What can we times 5 by to get 40, which is 8? So again, 5 times 2 to the x is equal to 5 times 8. 8 can be written as 2 to the power of 3. Now what we can do is we can ignore the scale multiplier of 5, and just giving us 2 to the power of x is equal to 2 to the power of 3. Common base, they can be ignored. Just look at the exponents. X is equal to 3. Another example. 3 times 1/2 raised to the power of x is equal to 12. Like before, expand out the fraction, find a value you can multiply by 3 to get you 12, and we get 3 times 1 to the power of x divided by 2 to the power of x is equal to 3 to the 4. Like before, let's take our denominator here, move it to the top, and find a common base of this value 4, which again we know is 2 to the power of 2. So we get 3 times 2 to the power of negative x is equal to 3 times 2 to the power of 2. The multiplying scalar of 3 can be ignored. Again, getting us, and the exponent bases of 2 can be ignored because they're the same as well, giving us negative x equal to 2, or x is equal to negative 2. One final example just to wrap this whole thing up. Okay, here we have 2 to the power of x multiplied by 4 raised to the power of 2 minus x equals to 3. First thing, let's get things of common base. So that gives us 2 to the power of x times 2 to the power of 2 raised to the power of 2 minus x is equal to 2 to the power of 3. When we have a power raised to a power, we can simply expand that out through multiplication. That then gives us, in here, 2 raised to the power of 4 minus 2x. Using our product law in here, because we have the same bases, we simply add these exponents together. So it gives over here 2 raised to the power of x plus 4 minus 2x is equal to 2 to the power of 3. We can simplify this part further simply to make this 2 raised to the power of 4 minus x is equal to 2 to the power of 3. Same base, just compare the exponents. So 4 minus x is equal to 3, so x is equal to 1. As I said at the beginning, the 3 key things you need. A, you must know your index laws and how to use them. B, you're always trying to find a common base or a common multiplying scalar which we can just get rid of and ignore. And then when we can just look at our exponents. And then, like I said, finally, a little bit of basic algebra. So let's give it a bit of practice in class.